Oops. I did it. Click the button. Clicked it. We can do a little bit. Do a little bit. But I don't know what we're doing. Because it's still broken. If we run it now, there's gonna be a big square and... Oh no, okay. We're not in square mode right now. We are in... are in broken voxel mode. But we should be in square mode. Huh? Oh. But yeah, there. Now we have a bunch of glitching pixels. That's what we want. So now we have to go into ray tracer. So what we need is we need a method that will take, it'll return float, and it's going to be called get smallest step delta, and it's gonna take a pool 3 mask, call it mask with big M, and it's going to take a float 3 delta, right? And then we have to do if mask.x and mask.y, then we do float temp return temp. Then here we say if mask x and mask y, then we do temp equals min mask delta dot x and delta dot y. I want this to be a large D too. Else if mask.x and mask.z, else if mask. God damn it. Mask.y and mask.z. Those are really all the checks, I believe. And we can also do an if mask x and mask y and mask z. Then we do a triple. Then here we do min delta y delta z. And this is an else if. And then we return that. And then we have to go to wherever we get a mask. Here. Well, anywhere really. No, this should actually be commented out so we can judge how it works. And then here we grab a mask, and then we have to say shit, we actually need it needs to return a bool 3. That's what it needs to return. Bool 3. So this is gonna be bool 3 temp, and then again we return temp. And if all 3 is true, then we do temp equals bool 3 I don't know a smart way of doing this. If delta.x is less than delta.y, and delta.x is less than delta.z, then temp equals bool 3 true, false, false. Else if delta dot y is less than delta dot x and delta dot y is less than delta dot z. And false, true, false. Else if z is less than that and that is less than y. This is really the only remaining option, so it doesn't really need an else if. If delta.x is less than delta.y, then true, else true, like that. And here, if x is less than z, then true, else true there, and false there. I think I've already done this though, and it didn't work. And here, if y is less than z, then true, false. They're true. False. Let's keep this. And now mask has to be, mask is equals less, what did I call it? Yet smallest delta. Mask delta this. And then every time we get a mask, we have to just double check the mask and get the smallest delta. I don't know if the smallest delta is what we want. It might be more complicated than that, but let's start there. There. So what does this do? Syntax error. Okay, where's my syntax error? There it is. It's gonna get worse. Last time it got worse, I think. Oh no, it's cured. It's completely cured. I think. I don't see anything, at least. I already tried this though, so why does it work now? Or maybe it's not cured and we're actually getting incorrect sides. I'm just not seeing them right now. Because now it won't trigger in the same way, but it might still be showing incorrect sides. But I'm not really seeing any. It was pretty noticeable before when you were like just going around. Alright. Let's try switching on traversal levels again. seems fine, I guess. Odds are this won't fix it, and if this doesn't fix it, then I don't know what we're going to do this stream, because I have no idea what the issue is, really. Nope, it doesn't fix it. So what is the issue? It's so weird. I guess it has to be the I guess it somehow has to be my ray reconstruction, but I don't understand how that could be wrong. It's so strange. And especially how it seems to be broken here specifically. When it works perfectly in a square setting. So why is that? And I feel I don't really get it. What did this look like originally? Ray container max. We can get a length now. Hold on, let me open. Guy showed me his code yesterday. Ponzu isn't just soy sauce with lemon sauce. Lemon juice? Okay. Where are you rebuilding it? Where's the length thing? Length. There, D. I needed to special order it? No, you don't. You don't need to make ponzu. Or you can make something close enough. So you do, let's see, D equals D equals length that no, you don't. You don't need to do that at all. Current ray position, ray origin plus ray direction times D, yeah? You live without Gato Squaw. Ray origin plus ray direction times D, current ray position. That's what I did before, but that didn't work. So how come you get to do that? You piece of shit. He just gets the length from here. Maybe this works now. There is a potential that what I was doing actually worked, but it got broken because of the double mask issue. So, current ray position. I don't understand how he gets away with not flooring. I still want this to be, like, unironically, this should still be minus side disk stored, right? And then this should be delta dist times DST. Purely like that. No, this is where I wanted the side disk stored to still be. It shouldn't be there. But this doesn't work either. That's the problem. And we did that there. So we'll go up and we'll do a traversal level limiter. It's greater than 1, then it's 1. And now we're back with this issue here. Now we have inaccuracies. Time. But basically, he's doing it a bit differently. He's taking the ray origin plus ray direction. How does that play in? What does the ray origin have to do with anything? So basically we should be able to just do this. Kind of. If we get rid of that. That should be possible. But I hate that the math doesn't match. It doesn't add up. Like, in the math that should be correct, it doesn't work, and I don't know why. But see, the side dist, it includes the bricks side dist here. So if I just multiply this up, there shouldn't be an issue. This though, is this what's weird? This should just be D. There. What about you? You should also be D. Maybe. I'm not so sure about that one. Wait, huh? What's the issue? No, that makes no sense. That needs to be DST. Nope. No, it just won't work. Now he's multiplying the ray direction by D. But we're not using the ray direction. Not in that sense. So that makes no sense here. We could try doing something with this. I'm not storing the current ray position exactly. I don't understand what he's doing here. Current ray position plus equals vector 3 mask times ray direction times 1e minus 3. So that's... what? That's 0.001? One E minus 3. Yeah. That's what I said. But he's not wrong. Like, we've fixed this. So the mask is no longer the culprit. So we have to face that this is not right. Still. It works somehow? But I don't understand really how. Because what happens is, we travel, let's say we travel a brick. Or let's say we're traveling a voxel from or into a new brick. Then we move to the right, for example. And if we move to the right and we set old voxel equals our previous voxel, and then we grab a new voxel, and if that voxel has a different brick index, then we iterate the brick in the same direction that we iterated the voxel, right? Then we set the old brick to be the brick, and we set a new brick to be whatever the voxel's brick index is. And then we use the brick to check if we're going into a wall, but we don't need to check that right now. And then after that, down here, I set in here, after all of these else if statements, I set old brick to be brick so that it's up to date as well. So that's what's happened here. We traveled a voxel into a new brick, so then we also iterated the brick. And I don't see how there are any issues here at all whatsoever. And then this all... if brick... Let's skip this. So we go into the brick, and what it checks is if the brick's color index does not equal 0. That means that it has something in it, because the color index is meant to be its LOD color, not quite properly implemented. So if it has a color, then we set the traversal level back to 0. Because we haven't skipped any voxels or anything, we're just saying continue traveling in voxel space. Else we travel in brick space. And here it goes into the wall here. And it iterates the wall, and it checks if the wall is empty or not. If it's not empty, then we go back to bricks. And then we go down here, and then it checks the brick, etc, etc. And here it also sets the old voxel. So then it iterates. There's nothing special, nothing happens up here at all. All it does here is it's currently checking if we are traveling in wall space, and then it just slaps it back down to bricks, because I don't want to travel in wall space right now. And this here, this just checks if we're out of bounds. And that's it. And then we enter brick traversal. Mask equals less than equal. We check the sides against the sides on brick. And then we get 1 or 2 sides. So here we check the proper smallest side to get, and that works. And then we iterate the side dist by the delta dist, the way it's supposed to be. The brick map position is iterated by the mask as well. Old brick is set to brick. We get the brick from the brick map position. If the brick is not the same wall index as the old brick, then we start traversing wall. But let's skip that again for now. And then here it checks, because we're currently in traversal level 1. So if we skip this, then we go down here. It says if traversal level 1 and brick.color index. We got the brick there, so that's correct, and we are in travel level 1. This means that there's something in this brick, the new brick. So we set traversal level to 0, and then we set all of this shit here. What happens is that we traveled into a new brick. And the way it works is that when you travel into the next space, it actually travels to the end of that space. So it goes from the edge of the previous one to the edge of the next one. So what happens here is that to rebuild the ray, we take we multiply the side dist, which is currently how far each axis has traveled in total. And we subtract the last axis from that. The last axis delta dist, which is the step, or how far it travels each step. So that means that we went into the next brick or wall, and we noticed that it has something in it, so we can't skip through it. That means that we have to back up, reconstruct the ray where we are, because now we are at the edge of that brick. So we reconstruct the ray there to the lower, one step lower, right? From wall to brick, or to brick to voxel space. And from there, we use the same direction, the same mask, and we travel in the lower resolution in again. And then if we traveled in wall, we're now traveling in brick space. Then we check the brick. Does the brick have anything in it? Yes, okay. Then we back up again. And then we travel in voxel space and do the same thing again. And it moves in there. And after it's moved in, all it really does is it goes down and runs the next step. And I don't know. I don't understand how there's any issues. Because the math should be fine. That's also what wrecks me. Maybe the map position here is wrong now. Like the D divided by delta dist. Yeah, because what if we do this? Float 3. Float 3D there. Because then we have so it has to be floored. Man. Man, it should be like this. Like, fuck you. It should be like this. The original side dist should be subtracted from the length. Like, it makes no sense. That it has to be that way. And then it should be like that, and it should be like that. That is how it should be. However, now that we have done that, this has to be side dist stored plus delta dist D. But this won't work. Like, I've done this so many times now, and it just does not work. Is that it? No, it doesn't work. so stupid. So how the hell do we do it? The only way I can think of doing it differently now is if we do this. We extract this. All of this crap. All of this. And instead of recreating the ray based on the side dist, we take the ray position and we take the ray direction and we multiply that by the length that we get. And then we use that as a new ray position. And that's the only way I can think of doing it that might have a chance in hell of working. That's also how he is doing it, I think, here. Here, vector 3 current ray position equals this. But he doesn't seem to be really caring about the like the delta dists and the side dists are all the same still. So I don't know. It's kind of weird. Is that vector 3 side distance equals ray direction. Yeah, he recalculates the side distance every time as well. It seems. Because here he gets a ray direction. Or he sends in a ray direction. And from main, he's got a loop that ray trace smaller, current ray position. And then he gets a ray trace result, which gives him his current ray position. So, yeah, that's basically what we have to do. And to me at least, that means that we have to take all of these and make them global. Well, we don't need ray step to be global. Map position, global. Brick map position, global. Wall map position, global. My feet are in pain. There. And now everything here, delta dist, ray direction, ray step. Ray step can stay the way it is, it doesn't matter. Map position, break map. Map index, we're not using that. And all of these. Yeah, like I said, we're not using map index. So then if we nab this, the delta dist does not need to be recalculated. Ray position does need to be recalculated. Fuck my feet. Map step also not using. Well, no, we are using that. But we don't need to recalculate that. It's these. And then we want void init array. And I don't know if we really want to give it anything. Okay, it does need raised up here. Ray position is there. Okay, they need to be global so I can use them without passing them in. Passing in is annoying. And then we simply init ray like that. So this is using map position and ray position, and map position gets set there. So what we need to do now is we need to go down here. And I think we might want not a ray position, but a load 3 ray origin. Ray origin equals ray position. And then we go down, 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 down here. So we get the D, and then we do ray position equals ray origin plus ray direction times D. And then we do init array, and then we just do that. I don't know if that's enough, but let's give it a go. That doesn't work at all. Cool. Oh, it doesn't. We don't do the move here. Let's see. Move it there. No? Wait, huh? Nope. Does not happen. Now the question is the ray direction fucked because it's normalized? Oh, no, no, no. We forgot to do init ray in the first place, so the ray doesn't exist. Well, it does something. Now we get a bunch of black areas. Which is kind of strange. Try removing the normalize. No, that doesn't help that. Black means... Black means we've run out of steps. So how is that possible? How can it be stuck forever? I kind of know why. I kind of get it. Let's try removing this. I don't like that, but it's worth a try. Then we do init ray, and in init ray we do this. And what's happening here now, and it gets really, really annoying, is that because I recreate the ray, well, let's be real. I am recreating the ray, and that means that we are... No, it's not guaranteed. But let's... Because what you had to do, right? You... Also, and this is wrong. Let's try running it with that as well. But it is still wrong. See, what's happening is that we recreate the ray, but the ray is recreated one step back in whatever space we were traveling in. And that means that the brick is one step back, the house is one step back, whatever it was there. And if this happens, once we, like, if we are somewhere when we increment the voxel, it also increments the brick and the wall. If we are in one of these spaces, then that causes desync, because the brick and the wall map position falls behind. So this actually needs a check for that, and that's what I don't really want to do. I see, it's a lot of code. So this has to be like that. That's what we do. Old voxel, we save the old voxel. In fact, the init ray already does that shit. It sets the voxel to the new map position there. And it also sets the old voxel. So all we need to do now is get the voxel, and then we do if voxel.brick index does not equal all voxel.brick index, then brick side dist, brick delta dist, brick map position, and then inside here we have to do brick. We have to do old brick equals brick. No, we don't need to do that. All we need to do is brick equals get brick, brick map. No. How do you do it? brick equals brick data buffer voxel dot brick index. That's what we do. And then we do if brick dot wall index does not equal old brick dot wall index, then wall side dist, wall delta dist, wall map position, wall equals brick data buffer voxel brick dot wall index, and then we set old wall equals wall. Here we set old brick equals brick, and here we set old voxel equals voxel. So that's how annoying it might be now. I'm not sure. If this even works, or if I'm just bragging ahead of time. I am using the wall data buffer. Not gonna work. Nope. Fuck off. What is this? This is so odd. It's stuck in a forever loop. But I don't really understand how. He never normalizes it. And I don't know if I need to normalize it, but even if I do or don't, it doesn't really solve anything. It doesn't really change it at all. So how does this happen? It's trying to... Is it because I'm recalculating? Let's just try the side dist. Let's just... Let's just rip the side dist out of the init entirely. And then we're left with this only. Which is... a lot less than I thought. Let's try this. And then here we set wall side dist to equals wall side dist stored. But this makes no sense. Worth a try though. Because I don't really understand what the issue is. No. It's terrible. doesn't work properly either. Even there, where it works, it seems it's not properly rendering. They really recalculate the side dist every single step? What? How is it getting stuck? I don't get it. It's so weird. How does it get stuck? It has to have something to do with the init array, but I don't get that either. Now we have to try this. Not seem to be that. Just thankful, but I also think that ran way worse. Yeah, that's like a 20 FPS drop at least. But every single red pixel is running maybe like 200, 300 too many steps anyway. And I don't understand why. It's like the bricks work just fine up here, right? But once you are next to something, how does that work? It's like it's checking. Let's... No. It's here, like it is this. So what's wrong with it? How does it get caught up forever? Maybe this side disk isn't right anymore. Maybe we need to get... But that makes no sense to me. That makes even less sense to me. Like getting a new mask here? That makes no sense. No, it did not. Alright, let's try this without init ray. So that we do not re-init the higher level. So we just keep this shit. Because we're moving down a level. Right, so that's our new position. And our new side dist. So is that it? Is it working correctly though? No. We've got some glitches over there. And we get some glitches over here. It's when you're standing right at a brick, I think. You get glitches. You see there. So there's still... It's better now, but this is still not good. Still glitchy. Why, you stupid bitch? Oh my god. Is it still normalized or is it not normal? Let's try changing the normalize. I just don't know if it matters in any way at all. It doesn't seem to do anything. I think it is kind of normalized already, so. Why is it doing this? There we see through. Oh, is that nice? Fuck off. What if we do something like... just as at a whim. Side dist equals ray position minus ray origin length times delta dist or something, I'm not sure. That didn't go very well. No, we can do the length trick here, right? So if we do d divided by length side dist, then we set side dist to dst times delta dist. Maybe. No, not side dist, delta dist. Not even close. No, this shouldn't be a float 3. This should be... Let's just set D to that. Fuck off. Like that's actually correct. It should be. I don't see how it's not. Like, fuck off. There's no way that causes that big of an issue. No. Just makes no sense. I don't get it. The brick side dist is the ray distance multiplied by 8, and it's correct. Like that part works as far as I know. And so then we extract the brick side dist that we last iterated. We take that, I'm not 100% convinced of this. Because I feel like maybe... maybe we're getting like the wrong ray. But I don't think that's the case either. Because if we reduce it, that means we get the lowest ray distance since last time, and from what I understand, the lowest ray distance is our position, basically. So that's what we get, because that's the direction that got chosen. So we have the right ray length. So then I take the ray length and I divide it by our delta distance. And I divide it by the same delta distance that... Does that make sense? Maybe it doesn't. I'm dividing it by the delta distance of the direction that we traveled. And maybe that's where things get weird. Because then it gets divided more if it's a long travel distance ray or delta. So then when I use that to multiply the other steps, yeah, that's where things get weird. So how do we get that? Maybe I need to do the division and floor method. And by that I mean we need DST equals D divided by a delta distance. That's what I did last time. And what you get then is you get how many steps each direction has traveled. And then you do side dist equals DST Lord times delta dist, because that way you multiply the other axes up as well, but you chop off the overflow that's not supposed to be there. But I don't know if that ends up being correct either. It might, but I don't think so necessarily. Because it might be that we have like array that's 100 or like 1.2, 1.1, and then we have one ray that's 4. And if that was the ray that we iterated, the 4, No, it should be fine. No, it might not be fine. Because we're actually iterating the lowest ray distance. So we might actually not be high enough. That might be a bigger issue. It might not be high enough. Maybe this should be sealed. Does that even work? I think it might be sealed. But it's not gonna work. But this is still wrong as well. Neither works. And you can't just do that. You get Croco mode. The floor approach begs that we add side disk stored, otherwise it won't work. But that also feels weird. And now we're basically back where we started. We have glitches and shit. Because the side disk, it's still not accurate, right? seal is also not accurate. And round is not gonna be accurate either. Oh. And it's not gonna be accurate with this. Nah, nothing wants to work. I want to go back to right after I removed init ray, I think. There. This is the closest we've been so far, but it still sucks. It has minor errors, and it's got some jitter there. But I don't know what might be causing it really. Because this, I don't like recreating the side disk. I want to recreate where in the side disk we were. Like, I want the side disk to be like it was where we started. It works decently, but I don't know. We might be able to do this. If we get a new ray position here, then we can set side dist to be, instead of basing it on the new position, we can set it to be side dist equals, this is just a guess, but if we take side dist stored plus ray position minus ray origin abs in 3. But they are already in 3s. No, they're not. Float 3. Float 3. Times delta dist. That might accurately recreate the delta dist. But I'm not convinced that's gonna fix it either. And it didn't. What if we abs first? Before it gets in 3, just so we're sure which way it gets truncated. Nope, still fucked. Oh, go fuck yourself in the ass, dude. Fuck you. How is it this difficult? Like, I genuinely don't get it. Why is it this hard? Should it be the other way around? I don't think so. No, it made no difference. Because if the ray position is the new position, then we take that and subtract it by that to get how far we've traveled, right? This is just a... I don't know, dude. I don't know how they get this to work with their stuff. Because it's like nothing works. Like I've tried so many different things and nothing works. And yet somehow everybody gets it to work. Like I don't get it. And they all seem to have based it on the same thing that I had based it on. Yet theirs are like completely different. And it just like it works. I guess. Either that or they're not accelerating it and they don't notice the pixels that are bugged. That's like the only thing I can imagine. So I think he's accelerating it, but it's hard. I can't read the code. Thank you, Max. So it's time to stop. It's almost midnight. Like, I don't get it. Because this is... that's what pisses me off. It's pretty much always correct. But it doesn't work anyway. So where is the issue? Like here? If this is accurate, if this new ray position is accurate, where we take the length of the ray and we multiply the ray direction and add it to the ray origin, if that is accurate, and that's what that guy is doing in his code, he is doing that. If that is accurate, then I should be able to take our original starting position, right? And I should be able to subtract that from our new position in integers, and that should tell us exactly how many steps we have moved in each axis accurately. And then I should just have to add that to our original side dist and multiply it up by delta dist, because because if we move one to the right, then we add the x delta dist. So if that is accurate, then that's what I should have to do. Right? Like, it makes no sense. That's why it's so annoying. It's so stupid. Unless my ray distance is broken. But I don't think it is. It might be. Or my delta distance, rather. But the delta distance, I made it so that it translates to the lower resolutions. So if we travel a whole brick, then that distance length is should be the same as if we have traveled that distance in voxel space. And because of that, I should be able to use it just straight up as it is to multiply and figure out how far in we are. But just won't let me. One thing that makes it difficult and might be part of what makes it inaccurate is if it is the lowest rain, if it's the smallest ray that we're using, the smallest side dist, then that might not be enough. It might not be enough to accurately reconstruct all three axes, because there might have to be a seal. Like, I unironically think there might have to be a seal involved, because if say we iterated an array that was like 4 in length, or in delta dist, or the axis is 4, and that brings it to like 12. But when we subtract it, that brings us down to 8. But what if, because it was the lowest, what if that one is 8, but the other rays are like 9 and 8.6? If we then use the 8 to recreate our position, then we might not accurately recreate that those rays are above us currently. That's what I'm worried about. So what if we get an abs here, and then we try sealing this? That's like the only thing I can imagine that might work. But then the map position might get weird here too. But I don't think so. Nope. Do not have an idea what a voxel engine and your issue is. A voxel engine is just Minecraft. Basically. A voxel is just a pixel is, you know, it's a position in a coordinate system, a 2D coordinate system. A voxel is just a 3D coordinate system. That's it. It's just like you have data in a 3-dimensional system, so you can like walk around on 3D tiles. Like that's all it is. But what I'm trying to do is I'm trying to normally when you render a 3D game, you create meshes for everything. Like you have the terrain is meshes. It's built up by triangles that build up polygons, and then you put textures on them, and then it just rasterizes that and renders it to the camera, right? But what I'm trying to do is I'm trying to render using raycasting. And then instead it doesn't have any triangles or anything like that. It literally just casts a ray out into space. And then we read from this like voxel tile network. And we check where in it we are, and we see if some voxel contains something. If that ray hits a voxel that has some dirt in it, then it renders a brown pixel, for example. That's what I'm trying to do. And the issue... It works. The raycasting rendering works, but what I'm trying to do is I'm trying to speed it up. Because when you're raycasting, you can use an algorithm that kind of understands where the next voxel is. So it steps through voxels instead of stepping like every 1 meter, for example. It knows exactly where the voxels are, so it doesn't miss any. But that means that it has to go through every voxel on the way, and if there are like 400 voxels, that means you're stepping... You're stepping through shitloads of voxels. So what I'm trying to do is I'm trying to like predetermine if space is empty, like large sections of space is empty, so that the ray can just skip to the other side of that area. But when I get to the other side, the ray doesn't understand properly where it is anymore, and I have to reconstruct that based on the skip. And it's just terrible. Voxels in general are pretty heavy, to be honest. You need to do a lot of tricky things to render them properly. Even if you use meshing, like Minecraft does, it's still very heavy, and raycasting is a very heavy technique as well. That's why you need to have stuff that like speeds it up and makes the rays not do so many checks. Yeah, I've seen that too, but I don't know how they do it. There are a lot of tricks you can do, but tricks aren't necessarily useful for actual products, always. But there are a lot of things you can do, yeah. But I still think you would prefer having a proper GPU. Anyway, I'm sad. Nothing wants to work, so we'll stop there. We have to work tomorrow anyway. Look, there's. So yeah, I'll see you later. Thanks for hanging. Have a good night. Bye bye.